Okay, we're going to factor some cubics that have a common x in order to solve them. So as I'm looking at this first one, x cubed plus 3x squared plus 2x equals 0. The first thing you should do when you're trying to factor is look for something in common, whether it's a constant, between the coefficients, something in common, or an x. And in this case, I'm looking and they all have an x, so I'm going to factor an x out in front. And then I have to think about what that leaves me inside the parentheses. X times something, if I was doing the distributive property to multiply it back out, it would have to give me x cubed. So this has got to be x squared, because x times x squared is x cubed. The next term has to give me 3x squared when I multiply it by x. And so I've got to have plus 3x. X times 3x would get me 3x squared. Okay, this last thing would have to get me 2x, so x times 2. Okay, and that's the main difference between factoring just regular quadratics and factoring cubics. As long as they have a common x, you can factor a cubic. As long as you can factor that x out, because then all you have is a quadratic, and you're just doing the same thing as when we factored quadratics. So now I just need to factor this quadratic that's left in these parentheses, or at least attempt to. And so I'm thinking that x squared plus 3x plus 2, it would have to be x times x in order to get x squared. I know that the two numbers here have to multiply to 2, so plus 1 and plus 2 is pretty much my only shot. I have to make sure that they do in fact give me 3x in the middle. This would be 2 times x would get me 2x, 1 times x would get me 1x, which adds to 3x. So it does in fact give me 3x in the middle, so that's how that factors. And if I'm trying to actually solve this, I now have three things I'm multiplying to equal 0. And any one of those things equaling 0 would make this thing equal 0. If this first part's 0, it doesn't matter what these other two things are. It's going to multiply to 0. If just this second part is 0 and the other two are something else, doesn't matter what they are, as long as this one part's 0, when I'm multiplying things and I'm multiplying by 0, I always get 0. So if any one of when any of these things are 0, I have a solution to my problem. So I have to find the x values that make that happen. Well, in this first one, x equals 0, that's just it. On the second one, I'm going to subtract 1 from each side just to get x equals -1. And here I'm going to subtract 2 from both sides to get x equals -2. And so my solution is all three of these, x equals 0, -1, and -2. Okay, so that's how you factor cubics that have a common x. Now over here on the right, it's kind of a similar problem, a little bit more challenging, that is going to involve, it actually is a fourth power, and also there's a 2 in front. These, when I look at them and I go to start factoring, I notice there's a 2, a -14, and a 12. So those terms all have a 2 in common. And x to the fourth, x cubed, and x squared, they also have x squared in common. So I can factor out 2x squared. Now, 2x squared times something is going to get me 2x to the fourth, and that's times x squared, because x squared times x squared is x to the fourth. And then what times 2x squared is going to get me -14x cubed? Well, 2 times -7 will get me the -14. X squared times x will get me the x cubed. Okay, now I have to figure out what 2x squared times would multiply to get me 12x squared. 2 times 6 will get me the 12, and there's no x's that need to be put down because x squared is already here, so we're going to be good with that. Okay, so now I've got 2x squared, and I've got this quadratic in the parentheses. If I can, I'd like to factor that. So x times x gets me the x squared, and I've got to add to -7x and multiply to 6. So I'm thinking that would get me -6 and -1. -6 times x is -6x. X times -1 is -1x. So those add to -7x, and then when I multiply those, I've got positive 6, which is what I needed to have. So that's correct. Now again, just like over on the left, any one of these things equaling 0 will make it multiply to 0. So I need to check, when is 2x squared equal to 0? Well, that happens when x equals 0. When does x minus 6 equal 0? That happens when x equals 6. And when does x minus 1 equal 0? That happens when x equals 1. So now I've got my solutions. X equals 0, 6, or 1 are numbers that if I plug them in up here, that this equation would equal 0.